if you've been watching all the videos up until now, you would have noticed that all the questions I've set so far is firing the cannonball vertically upwards. So the cannonball will either go up or it will go down. Now we need to think about the horizontal direction. So in the past, I've always asked you this question again and again. So I might as well ask you one more time. If I were to drop a cannonball and a snooker ball here, standing on top of a building, which one will hit the ground first? Now, your average adult will probably say, "Oh, this one here is heavier, so it will hit the ground. It will hit the ground first." But in fact, they will hit the ground at the same time. It's independent of the heaviness or the mass of the two. It's independent of the mass of the two. So now let me ask you a new question. So here I've got myself a table here. Suppose I were to drop a snooker ball here. So option one is just drop a snooker ball, but drop it from rest. So this is option one, dropping a snooker ball from rest. So it's going to go in this direction, okay? Or option two, where I'm gonna have a snooker ball here, identical snooker ball, same mass, but I'm gonna give it a push. So I'm going to give it a horizontal velocity. I'm going to give it a push basically. So the second snooker ball will travel something like this. Like it's badly drawn, but it will travel something like that. Okay. So option one is the snooker ball will be dropped at rest. Or option two, where you give it a push, but remember, this one will travel something like this, okay? But by the time snooker ball two gets to this point here, the exact same point, I'm going to release ball one as well. So they're released at the same. Well, ball one will be released at the same time as when the so this bit here doesn't count. It only counts when ball two gets to the exact same position. Okay, so option one would travel downwards like this. Option two would travel in this path here. Now, which snooker ball will hit the ground first? So yeah, I think you get the point now. Option one, dropping it down vertically like this. Option two, remember, we're giving it a push, but I don't really care about this bit. I only care when it gets to the exact same position as option one. But option two would travel something like this. Now, which one would hit the ground first? So press pause and think about it. Okay, the answer is that well, hang on. Let me give you let me show you it. Hang on. So option one would travel like this. Okay, so let's just say this is one moment in time. This is an equal space in time. So let's say this is 0 second, 1 second. Let's just say, okay, 2, 3 seconds, and 4 seconds here. Okay, that's option one. But the thing is, option two would look like this. Now, t equals zeros here. T equals 1. 1 second later it will be here. 2 seconds later it will be here. 3 seconds later it will be here. 4 seconds later it will be here. The point is that they both will hit the ground at the same time, because it's just the way it is, because that's what's happening in nature here. You just have to accept it. That's just the way it is. Well, just accept it. It's what's happening in nature. So I guess you just have to accept it. It looks like that. Okay. In the next video, I will give you some more examples. Okay.